Great. Video on. Cool. Share screen. All right. Minimize my floating head. Okay, so this lab we're going to do today is all about the central limit theorem. Now, the central limit theorem just has to be bigger than 30, right? So when we look at our numbers, something should change when we get bigger than 30. You will find out how and why. Now, a lot of this stuff is trying to think about the best way to put it. So we're going to do a simulation. Simulations are very useful for statistics. Do you want to run formulas 50 times, 100 times, 1,000 times? No. That's why we have computers. So statistics kind of leans on computers to run it a bunch of times. So we get to do our first simulation. I use simulations all the time when I'm running stuff. It's nice to see exactly how it look if I ran my study 1,000 times, right? That's what a simulation lets you do. As soon as we hit 30, though, we should be able to see the shape that we want. Okay. So that was a little intro. So where is this lab? The first step is go to modules. And I'm going to give you some tips. Okay. You're going to go to lab 3, the last lab. Can't believe we already did all 3 labs, but it happens. So here is lab 3, central limit theorem. Okay, it's windy. So you download this. I opened it in Word. You can open it whatever you want. And you should see, where is it? I think this is it. Yeah, this is a blank one. Cool. You should see this. I want to make sure everybody sees this first before I move. So everybody looking at this. I'm going to wait till I see more nods. I don't have all my nods. Okay. How about Miles, how about you just read under binomial distribution investigation?
For this section, you will use StatCrunch and MML. Use the following menus items: stat, calculators, binomial. With the binomial distribution, you are to use the options in the following table. If you are changing the values, please note: 1, the shape of the curve as you change n and keep p constant. 2, the shape of the curve as you change p and keep n constant. Complete the table below to help keep track of the patterns. X and Y coordinates of peaks can be approximate.
All right, so there was so much there. He said so much, beautifully said. The first thing I'm going to do, since I have to fill out this table and I'm going to get confused, the first thing I'm going to do is I'm going to shade the table. So when I look at the table, it makes sense to me. You can shade it however you want, but I'm going to just fill in some shade so every line will look different. Now, you can fill in shade. Oh, here comes the rain. You can fill in shade for just going 0.5s to 2s to 8. If you want to just make all of these one color, I like going every other line, but that is just me. I'm recommending you now shade your table. So when you have to put everything in, you don't get confused on the parts. Anybody lost? I'm just shading. We got no fear, right? Why am I shading this table? It's because my eyes are really bad. And if we have a table with this many things and we want to look at it, that will work. A good way to shade it, if you don't like going every other one, is to shade all of the 0.5s a shade, all of the 0.2s a shade, and all the 0.8s a shade, because that's what we want to compare. We want to compare with a 50% probability of success to a 2% probability of success to an 8% probability of success. All right. Are we okay? Can we get started? Feel good? Looks a little different. You got a couple of shades. So when you plug it in, it doesn't look weird. All right. So I'm going to go through this very slowly so nobody's lost. I'm going to drag this to the side. I'm going to click wherever I was, and I'm going to go to Axis Pearson. What weird weather. Open Pearson. I'm going to make it a little bit smaller. I'm going to open my MATLAB and Mastery. Okay. And I'm going to go to StatCrunch. And in StatCrunch, I'm going to open a blank page. You just need a blank page. So go to StatCrunch website. StatCrunch login error. That's always awesome for me. So I'm going to log in again. Worked this time. So I'm just going to open a random data set because mine didn't want to open the first time. So StatCrunch, new data table. Here should look like this, blank, right? Everybody have a blank data table? I like the nodding. Cool. All right, so the first thing is we're going to go to stat calculator, binomial. Boom. This is all we're going to look at until we do the simulations. Does everybody have this pretty screen? We're good? Cool. So here's your first step. The first one, we want 0.5 for probability of success. That's right here. That's the 0.5. Oh, for those who are going to watch this, there's the 0.5. Now it says our sample size has to be 5. Where does it say n? This is n. I have to change it to what? 5. And that's it. You just click compute. You see? That's all I did, right? Was that okay? Did everybody see that? Now, they're asking you for the peak. It's a point. The top, the acme, the top part of the curve is the peak. We need the x value and the y. The x is halfway between 2 and 3, which is 2.5. What are we going to guess? 3.5 that would probably be, or 3.25? Do we agree? It's probably going to do this. That's what I'm going to put. So my x, it's a point, so we need parentheses. My x is 2.5. My y is about 33%, 30, like whatever you want it to be. It says we can round 0.35. That's what I'm going with. Now, what's my shape? It looks normal. Oh, our choices are symmetrical, left or right. I'm going symmetrical. We did the first line. I'm going to pause now for questions. Who's lost? Okay, guess what I changed? I changed this n from 5 to what? 10. Look, it changed. Is it still symmetrical? Okay. Oh man, we're pros right now. And Ashley, please let me know if I can help you. Okay. So what is my x coordinate? Alejandro, tell me. Oh my God, great job. SB, what is my y component? Give me a guess. So what does this mean for us? Notice that the y is going down. That means the percentage of this happening is falling the more sample we have. Does that make sense? It's harder to get the middle when this grows. Maybe you'll see when we do a couple more. So guess what? Here's the third step. Now the 10 is going to turn into a what? Aryeh, tell me. What do we got? What's my new n?
22.
So close.
Oh, 10.
Somebody else help me. I'm all lost. It should be 20. So I'm just changing the n every time here. This doesn't change. This 0.05 doesn't change. And then I'm just hitting enter. Okay. You're going to see patterns. Look, 2.5, 5. Guess what the next one's going to be? 10. Soon you will be able to see all the patterns. You won't actually have to put it in. Okay. And Leah, what's the height? Give me a good guess. Point something. 0.2? I'm guessing 0.175, but you can put 0.2 if you want. We're estimating. This is 1.5. 0.2 is probably up here. Yeah. So, and Ashley, all I did, I'm going to redo it, okay? I'm in StatCrunch. I go to, let me use my brain, stat calculator. And we're doing binomial. Just want to make sure before I clicked it. And all I'm doing is basically taking each one of these ends and putting them in here. And I'm just finding the middle, the highest point. You're very welcome. Okay. Well, yeah, just so when you get there, okay? And the whole thing's being recorded, I promise. All right, so I just put in, we did 10, right? Oh, wait, is it still symmetrical? Cool. All right, here's the next one. Now n is going to be what? 40, right? Okay, I need some help. Kelly, can you help me out? What is the peak? I like 20. And what about the y? 125? Is that what you said? As long as this number keeps shrinking and this number keeps doubling, we're good. Okay? We should see a pattern here as well. If you don't see the pattern yet, that's okay. Because we're estimating here, you might not fully see it yet, but we'll get there. Cynthia, you good? You sure? All right. Somebody give me the next n. Alejandro, what do we got? 80. Great job. So I'm changing this n to 80. And this is, it's been symmetrical every time, right? That will change soon, I promise. Okay, so now at 80, who sees the middle? Nat, can you help me out? What's the middle for 80? I appreciate you. And do you know the height? I'm gonna go with 0.085. It's okay if you're not perfect, right? We can estimate here. If you don't fully see the pattern, that's okay. We have two more of these. I need some more help. SB, what's my new N? Oh, look at us. We're pros. Is it still symmetrical? All right. Does anybody see my X value? Great job, Leah. And Cynthia, what's my Y? 0.065. Is that okay? It's whatever you want it to be, as long as it's getting smaller. Oh, can you not see? Is that okay? I'll try my best to make it as big as I can. Is that good? All right, cool. All right, last one. My last N is 320, right? Okay. Okay, and now we went from 80 to what? 160. Can we at least see this pattern? 2.5, 5, 10, 20, 40, 80, 160. Does that pattern make sense to us? Cool. Maybe we don't see this one, that's okay. If we don't see that one, I'll survive. Miles, what's the last height?
Height,
Yeah, I need the height.
0.0045.
I'll take that. I will take that because that one's right. Okay, so we did the first part of our lab, right? We did the first part of our lab. Are we any questions? Now we have to change some things. What is the probability of success? It's flipping a coin. Does that make sense? That it's symmetrical the whole time? Should it always be symmetrical if it's a 50% probability? Yes. However, things are about to change. Now it's only a 20% chance of it happening. So I have to go to the P and change this to 0.2. And we're going to start with what? Just a 5. Are we still symmetrical? We are skewed to the right. It's always where the tail is, okay? So this is right skewed. Now, I promise you that even though this is right skewed, as soon as we hit 40, what should happen? If I hit 40, if we do the sampling more than 30 times, it should become a bell curve. Okay? That's like the whole idea. This is showing you the central limit theorem. If I take 5 samples, 10 samples, 20 samples, it doesn't matter. But as soon as I hit 40 samples, this should turn into the bell curve. Because I'm pulling more samples out, it should mimic the normal curve. Okay? Now, we still have to do the same thing. So we should see a pattern for X's and Y's as well. So we should see a pattern for X and Y on the peak, and we should see this pattern change. So let's see if we can find all the patterns. It's pretty much what statistics is. It's like trying to see the pattern. So REA, here's the first one. Do you see the peak? I like 1. 1, and what's the other number? It's just 40%. 0.4 is perfect. So this is perfect. You see it's right there. There's the peak. Now I have to change this from n, my sample's gonna grow from 5 to 10. Let's look at it. See how it's getting more bell curved? You see how it's getting more symmetrical? Is it still right skewed? Yes. All right, is anybody lost? Did I lose anybody? Please don't be afraid to ask a question. All right. Tenzin, can you give me the new peak? I trust you. Where's my peak? Where's the highest point? 2, and what's the y? That's it, 3/10. Beautiful. We should start to see a pattern. Starting to see a pattern down here. 1, 2.4.3. Okay. Let's keep going. My next one is 20. All right. Is it still right skewed? Yes. But can anybody give me the new peak? Alejandro, I need your help. Where's my peak at? Well, we're starting at 4, right? Always X before Y like the alphabet. So 1, 2, 3, 4. And you see how this goes up by 0.15? So that can't be 0.3 yet. Does that make sense? And we know here it's got to be smaller. 0.4, 0.3, it has to be smaller than 0.3. You see? You see the scale here? So I'm going with 0.225 based on this idea. But that is me. You can put what you want. Just make sure it's less than 0.3. Is that okay? All right. Now, when I go 40, this better be a bell curve, because that's like the whole point of the lab. Does it look like a bell curve? Did you watch it just change? So now instead of right skewed, guess what I get to put? Symmetrical. Our new middle is what? I'm trusting people to see it. 1, 2, 4, 8. You see the pattern? Times 2, times 2, times 2. So here's 8. And our new peak is 0.155? I think so. Please let me know if I'm way off. Does that look okay? No, it's probably not that. It's probably 0.1525 or something crazy like that. But you can be as close as you want it to be. All right. I'm going 80. What comes after 8? 1, 2, 4, 8. What do we know it's got to be? 16. Is it 16? Looks like 16. Is it still symmetric? Oh, yeah. All right. Who can try to guess what this is now? I think it's 0.125, right? Doesn't that make sense? It should look like a pattern. Should look like we're building a pattern. All right, I'll do the last two, and then guess what? You guys get to do 0.8 yourself. Isn't that exciting for me? So here's 160. I'll do this one after 16. We know it's got to be 32. And after 320, we know it's got to be 64. We already know these are both going to be symmetrical. Boom, boom. All right, so 32 looks like it's at point. Is that a perfect 0.8? 0.075 maybe? And finally, the last one at 320. We know it's 64. My eyes are terrible. 0.0, 0.05? 0.055? Probably. Cool. So, what do I want you to do? All I want you to do is try 0.8 yourself. If you think you got 0.8, raise your hand, and guess what I'll do? I'll check it and make sure it's correct, and then we get to do simulations. Please let me know if I did that way too fast. Is that okay? Yeah? All right, I'm going to walk around in case you don't feel comfortable raising your hands. Keep feeling good. Cool. Made yours pink? I like it. Yours looks good. Are you okay? Cool. Are you writing them over here?
Yeah.
Okay, cool. Are you, do you need my help though? You're gonna log into the stack lunch, right? Okay. Take your time. It's not going anywhere, I promise. Are you good? Oh, I like it. You got the 3 colors. That's cool. Do you see any of the patterns? Right? These are all doubling. Cool. And this is starting at left. Perfect. Now I came to check on you. How do you feeling?
I think I'm pretty good.
You already flew through it?
Almost.
Okay, so if it was too easy for you, maybe try the simulation.
Okay, sounds good.
So I'm gonna make sure we're all together on the same page, or feel free to help somebody. This easy?
Yeah, it's just like trying to figure out when it gets a little bit harder.
Oh, wait, it's just an estimation. That doesn't matter, really. Okay? Just a guess.
We're bringing.
Why is yours point? Oh,
Um.
so that's in the C. We could use that. Yeah, that's it.
And then which one did you write down?
4 is the height.
Okay.
4 and point
The
4.
highest one.
Yeah, that's the top, and it's not right skewed anymore. It's left skewed.
Okay. Which is.
Are you okay? Cool. I like it.
Oh, I'm still on 20. What are you on?
Don't be afraid to ask me for help. Make sure it turns symmetrical after 20, right? If yours doesn't get symmetrical after 20, you made a mistake. Look at this. I've got statisticians all over the place. You're ready to move on? All right, so how about you? I'm gonna just put these in for folks. I'm gonna put right. Oh, sorry, I'm a big liar. Left skewed. And I'll ask you for some help. So we have 3 left skewed. And then they should all get what? Symmetrical, 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 symmetrical. So this one has to start at 0.8 and we're starting with 5. I got 4.4. Did everybody get 4.4? Yeah, 4 and 0.4. Cool. If you're done, feel free to write in the next pieces, right? Since you're done already, like fill out the word parts. Oh, well, you're way too ahead of the game. Sorry. So I'm gonna just slowly put these in because I don't want to go too fast for anybody. You can try the simulation if you want. So now we have 8 and 0.3. Did everybody get that for the second one? We feel good? All right, so the next one, if I go 4 and then 8, what do we think the next one's going to be? Maybe 16? Yes. So I got 16 and what is that, 0.225? Is that what people wrote? I don't know what you guys wrote. But I know after 16 comes a 32. 32 and 0.15. All right. The next one is 80. So after 62, we have, after 32, we have 64. 0.125. After 64, we're going 128, right? I think that makes sense. So for 160, you should have 128. Oh my God, my eyes. I'm going 0.08. And the last one. What's double 128? Who knows? That is correct. Look at us go. So write in what you like. I got 0.055. I like that. So make sure when you're looking at these patterns, this is everything, right? I already put in all the answers for you. Ta-da! So the next part will be different for everybody. Isn't that exciting? Because we're doing simulation, so all of your answers will be different. So no matter what you have, will be particular for your computer when you click it. Okay? So what I get won't look like yours. That's okay. All right? Before I move on, the patterns are what? As the sample size increases, the X doubles and the Y's decrease. You write that, I'd give it full points. What happens with the skewness? As soon as we pass 20, sorry, as soon as we pass 30, they always turn symmetrical. I don't know what else to write. Does anybody see other patterns? Any other patterns people see? If you don't see other patterns, I'm totally cool. I'm chill. All right. So I like that this is 0.8 and we're starting with half of that. This is 0.2, we start with half of that. Do you guys see that? Or is that just me who sees it? So yeah, this is 0.2. We're starting with 1, we're doubling every time. This is 0.8. We're starting with 4 and we're doubling every time. It's like half of what the probability of success is starts your max. Isn't that kind of interesting? Those are just other patterns. There's a bunch more. But those are patterns that I'm seeing. Does anybody else see a pattern? If you don't, that's okay. All right, let's move on. Okay, so here's the part where everybody messed this up. Write what you want in these points, I'll be fine. And I've been talking all day. Can I get a volunteer just to read this paragraph for me? Is that okay? Anybody will feel like talking for a paragraph? Okay, thank you.
There are two parts of the central limit theorem that are important. One that indicates that no matter what distribution you start with, the sample means a normal distribution as the sample size increases. A second is that the standard deviation of the sample means will be
That's standard deviation over square root of n.
the first part of this lab should help verify that the first part, sample means approach a normal distribution as the sample size increases for a binomial distribution. To prove the second part is difficult, we can at least get an idea if it works with the following problems.
So the first one should be really easy. As long as the sample mean increases, we get the bell curve. That's all it's trying to show you. If we're past 30, we're good to go. The second part, it's going to be harder to see these patterns, but we can try our best. Okay. If we don't see them right away, that's okay. All right. I'm going to do this really slowly. Okay. So choose the following options in StatCrunch to launch the simulation. We're going to applets. So we haven't done that yet. So here we go. We get to go to applets. It's the second one. There's so many. So applets basically just means simulation. If you ever see applet, it means it's going to run a bunch for you. So we go to applet and then we go to sampling. Sampling, sampling, sampling. Now you have choices. We have resampling. No, we just want sampling distribution. Should give you this picture. Okay. Now we're going to start with uniform, but we're going to change it. Okay. It's going to change. But for right now, it's uniform. They want to set the population to uniform. If it wasn't click it for yourself. A lower bound of 0. 0 should be there already. And an upper bound of 50. It's there already. Okay, so it should be set up for you to start that way. Is that okay? Now, all you have to do is click compute and it starts it for you. Okay, so when you click compute, you should all get this screen. It's going to give you some stuff. So we right away know our mean, median, and standard deviation. I have 25, 25, and 14.4309. So we have to put these in. Those are our first things. So our population mean, I'm going to type it in. Okay, our mean says 25. Our standard deviation says 14.4309. Now this is where things get tricky, okay? This is where kind of everybody gets a little lost, so really try to bear with me. Notice it says on top, we can do this 1 time, 5 times, 1,000 times. If you ever feel like you get lost, click the reset, okay? The first one, you see how these are all uniform. The first one, we want 5 samples. We're going to do this 5 times. That's 5 samples. We're going to do it 5 times with an N of what? 2. So look what happens when I click the 5. You ready? It's going to do it 5 times. It only does it the first one. Yours will not look like mine, okay? Yours will not look like mine. So we have 5 samples. You see that? See it says 5 samples. Our sample size was 2. Now I have to put in the mean. What is my mean? It's down here. My mean was what? My mean was 22.7361. I bet nobody else's is that, right? You put your own, okay? My standard deviation is 13.2083. Is anybody's the same as mine? No. However, when we go bigger, ours should all start getting closer, okay? Sorry, can you see? Can you see?
Yeah.
You sure? I can try to make them all a bit bigger, but this is what I put in. I took this number. Sorry. I took that number and I dropped it in for the mean. I took this number and I dropped it in for my standard deviation. But now we have to change it. What is the only change I'm doing? Now, instead of an N of 2, my sample size has to change to what? 25. Okay? And are we still doing this 5 times? Yes. So I clicked 5 times and it automatically did it. You saw that? Everything changed. So now my mean is 27.4838. And what is my standard deviation? 3.644. Are they closer to yours? They should be a little bit closer. They'll get a lot closer when we do this 1,000 times. Okay. Are we ready to see me do the 1,000 times or no? Okay, so I'm going to do this because you guys are going to have to do the other 2 yourselves. So here it is. So I go back to this sample size and I change it back to a 2. And I want to do this 1,000 times. So now instead of clicking 5, I click what? 1,000. Boom. See? You see how it's getting closer to the bell curve down here? This is 1,000 times for the sample means. And now these are the 2 numbers I use. Look, it gets so much closer to the mean now. Now I'm at 24. Everybody should be pretty close to 24.578. You'd be a little above or a little below, but you should be close to 25 now. And my standard deviation is 10.1267. And now I have to change the sample size to 25 and click 1,000. Boom. Now I should be the closest I am to the mean now, which is 24.807. That's very close to 25, right? And my standard deviation should get what? Smaller. 2.8732. So your answers will not look like mine, okay? That's okay. However, as we drop down, these numbers should get closer to 25. That's the first pattern, okay? If you did this correctly,
These two means should be closer to 25. The other thing you should have on your numbers is what? As this gets bigger, right? Our n gets bigger, your standard deviation should get smaller. Do these two numbers, are these smaller for you? Are your standard deviations, the second ones, are they smaller? And these two numbers should be closer to 25. Are these two numbers closer to 25 for you? If they are, guess what? You get to try the next part yourself. I'll at least set it up for you though. So notice that the next time we're changing this, okay? So is everybody ready for me to change it or no? Ready? I need a nod. Okay, cool. All right, so now we have to hit the edit button. So I go here. There's not an edit button. You click the option button. Oh, sorry, edit the option. So we click the options at the top. Okay, then we go to edit. Now we're going to what? It was uniform, but now we're going right skewed. Boom. Did we change anything else? Use the options and set the sample size below. Oh, no, that's it. So all you have to do is go to options, click right skewed, click compute. And we have to start with our mean and standard deviation and then do the same process. So my population mean is 14.0519. And my population standard deviation for this one is 11.8255. What do I want you to do? Try. Just try. Okay? Try the skewed one. If you want me to sit with you, I'll sit with you. But I really want you to either work with a partner or work by yourself and see if you can fill out this table. And I already forgot to change this and highlight these because my eyes are bad. When I highlight them, I feel like it's so much easier to see the patterns, but maybe that's just me. If anybody wants me to sit with them, let me know. You could always hit the reset button if you're scared, okay? Cool. What is for us? Might help. Cool. See if you can find the pattern. So for this one, you did options, edit. You didn't change it to right skewed. That was your mistake, okay? Now you work from it. This is your mean, that's your standard deviation, and then you change this, okay? You sure? Right. No, with these two. This means the standard deviation, because that's just for the sample, but what the sample means, okay? You're welcome. I'm not gonna mess with you. Do you think you got it? You got it. We lost. No, yeah, this is supposed to get really close. Oh. It could have been not, no, because this is 25. So the means for these two. Oh no, that's interesting. That's okay. It's just probably how you sample. Did you change anything else? That's okay, as long as these two are smaller, but these two should be closer than now. That's what's a little weird.
Yeah, I tried to redo it.
And it's same thing.
Yeah.
Okay, that's okay. Go to the next one. It could be because it's skewed.
Okay.
So keep going. That's just something you're noticing. I'll do it on the board too. Maybe I get the same thing. Not gonna bother you then. How are you doing? Yeah, you feel good? Cool. How are you doing? Wow, everybody's good? All right, I guess my directions weren't so bad.
Alright, let's see what happens when I do mine. Hopefully we get the same pattern, right? We're flying through this lab. Look at us go. Alright, so here it is. The first one is for 2, and we want it for 5 times. I got my mean. Come on, you can do it. Number 5. Okay, so my first mean was 16.7303. My standard deviation was 5.5661. It's okay if that's not yours. Now I'm changing this to what? 25, which means my standard deviation should get smaller. 5 times. Boom. It's not much smaller, right? 4.9. What is that? 883. And my mean is 13.9924. Now we're going to do the same thing. I'm going to change this to a 2. I'm going to do it 1,000. All right, my mean is now closer to the population mean, which should be, right? 14.1534. And that, don't worry about it. It's probably just the luck of the draw. When you just sample it 5 times, it could totally happen. All right. All right, and my standard deviation should be big, 8.5173. And here's my last one, 25 at 1,000. So here we go. Now my mean should be really close. Look, it's now 13.97. Actually, no, they're all really close. My 25 was really close to yours. So 13.9728. And my standard deviation is 2.3558. So what do you have to do now? You just have to do this. And now we're changing it to what? What are we changing it to? Options, edit. We want to change it to bell-shaped with a mean of 25 and a standard deviation of 5 and click compute. Beautiful. My mean is now what? 25. My standard deviation is 5. We should have all had the same thing. Yes. I'll do that as many times as you want. So options, edit. We were here at right. I went to bell-shaped. Why? Because it said go to bell-shaped. And then it says mean of 25. I didn't even change it. It was like that. And it said standard deviation of 5. And then all I'm hitting is compute. And we should all have the same, okay? We should all have 25 and 5 to start, right? So everybody's look the same? All right. So all you have to do is finish it up. Work with a partner. Make a friend. You know, everybody works by themselves quietly, but that's okay. You're already done? Cool. Is there stuff? Yeah, that's gonna be what we look at. Is there any questions on the test that you're worried about? Okay, well, if you want to look through it, that's what we use the rest of the time for. If anybody's afraid of these. We'll talk about whatever questions you want.
And what was it do again?
Oh my God, I don't know, like the end of the following week, you got like a whole extra week to work on it. I just wanted to give you a full class period and a little bit. Here, you feel good.
Yes, the only thing is. No, okay. I don't know how I got this.
For that one?
Yeah.
No, you have the same 25 and 5. Oh, you mean for the first one?
Mhm.
It should be different than mine for the population.
For this one?
Yeah. That will happen. The only one that's gonna be the same as the last one, because we
Okay.
use the exact same value.
Okay.
Is that okay?
Yes, it was just.
Oh, it's cool. You're doing good. So don't be afraid to put this in. So you gotta put this 25 and this 5, okay? Your mean is 25.01. It's here. You use these two always. We don't care about the samples, we just care about the sample mean. That's the central limit theorem. We don't care about the individual samples, we care about the sampling of all the means, because that's what makes the curve. So don't use this line. Use these lines, okay? Always the bottom 2 lines. Use the simulation. Yes, that's why I'm here. And you can pull it up if you want to work on your computer and just write your answers on here. A lot of people were doing that, so they can like type this in easier.
So you can go right here to wherever I put it. Where did I put it? Oh, does it not come up for you? I can pull, if it's hidden for you, I'll change that.
I don't mind that part, I can. That's a second.
I'll help you in a moment. So I'm just gonna go to modules for a second. If I made it like hidden, I will change that. There it is. Oh yeah, I had it turned off. All right, now you should be able to see it if you just reload your page and then you can open it and mess with it, okay? If you want, if that's easier for you to work with the data.
Then
For number 3.
repeat values. What is the?
Should be 0.05,
25.
as long as it's below 0.05. It's,
Um,
yeah, or unless it's medical, then it has to be below 0.01. Yes.
It is for the chief.
I don't know if it's different for everybody. So show me your thing.
I'm
Yeah, that's what you're supposed to do. Did you play, did you have 25 and you played 5 times?
Yeah.
Then that's all you did. That's all you need to do. You're
So
good.
it's always this one.
Yeah, oh, because this is the sampling of the means, so this is what we look at. This is true, but this is the ones we use. Yes, sir? Cool. So, yeah, you done?
Yeah.
Double lab, you ready to answers and everything? Oh, great. You're good. So at the end, answer the questions. You should see that. Doesn't have to be very specific. Everybody should get 100 on this lab, since I put in all the answers for you.
The P value is the chance that it's false or the chance that it's.
So the best way to think about it is the p-value is that it's not due to chance. So if it's 0.05, that means 95% sure it's not due to chance. So this means we're 5% due to chance. So the p-value of 54, that means it's
It's gonna be 1 minus that will give.
what you were likely to be due to chance. That helps.
Yeah, that makes sense.
Okay. What are we looking at? All right, so let's look at these last 3 questions, right? Alejandro, read the first one. What does it say?
Describe the change in the distribution, mean, standard deviation, and skew as number of samples change, sample size change, the distribution change.
All right, so there's 3 things we have to answer here, right? So let's not mess this up. So what are the 3 things we have to hit? We have to describe the change in the distribution, mean, and standard deviation and skew, right? So first of all, what does skew mean? Does it go that way or does it go that way? If you weren't looking at the graph, how fast is it for you to be able to just type it in again? Ready? So for 2, there's 5 times. Oh, I have to wait for the first one. I always forget. So the skew, we just look at the bottom, right? Sorry, we look at the bottom. How do I bring this up? It will not let me bring it up. There we go. So we're just looking down here at the bottom. So how does this change if I go from 2 to 25, right? Looks more normal, right? Now, how does that skew change if I go from 2 1,000 times? And now if I go from 25 to 1,000 times, you don't think there's much of a change, right? There's not much of a change. I think it went from spread out to really thin. Did everybody just see that? Look at it at 2. See how it's like spread out right here? The skew spread. And now when I click 25 and I go 1,000, gets really thin. So like those are kind of patterns that you want to see. Is it the same though? Is that the same for each of them? I don't remember. I'm very forgetful. I click options, edit. Let's see uniform. Right? Let's go 2.5. You always have to wait for the first simulation because it's running it. So let's go 25. Can't really tell, right? At the bottom. But now if I go 1,000, it goes from really spread out to really thin, right? So that's a pattern, right? So that's something that I would say, like it gets more normal and it like all of it goes from spread out to thin together. That's just the first one I looked at. But we don't just have to answer the skewness. They want to know what's happening with these numbers. I always think that the means, the bigger you get, look, the closer it is. My mean is 25. And look at my sample means 25.0098. That's almost exactly the same. When this gets bigger, my mean should get super close. And the bigger this number is, the smaller my standard. So just those are like the three main ideas. But if you see any other patterns, or if you saw any patterns, you could always just click it again. You don't have to redo the box, right? You could just click it again and be like, oh, I see this now. Oh, now I'm paying attention to mean and standard deviation, but you have them all on your chart, right? You should have them all written down. It looks like these are getting closer, but is this one as consistent? No, for my sample, I got the same thing as Nat, where look, all three of these are the same for the skewed. See how the mean is automatically getting closer to it for this one? So I'd write that it's not consistent through all three. I just said a whole lot. Just look at it, see if you can see differences between the means, standard deviations, skewness. I think that's all they asked you for, right? Were those the three things? I want to make sure I'm not leaving you in the lurch. Yeah, so mean, standard deviations, and skew. That's it. So can you answer those three questions for each of the samples? Do you see a pattern? Can we handle answering those? Yeah? Cool. And I'll help anybody else. Just raise your hands, okay? So remember, the P we want small, and the critical value we just want more than the test value.
So the one that we want to be higher.
Yeah, we want to be higher than that for it to be significant. That's why I'm here, right? If you're done and you want to start looking at your test, we have some time. But that's what we're gonna do all next class. I want to make sure we get 100. Feeling good?
Yes.
Oh, wait, oh, you were here, that's why. You weren't here either, SB? Yeah.
Oh, that's true.
Oh, yeah, you ran away. Because you had to write your papers. I saw it. It's fine. I have extra copies of everything. I stay prepared. She came and then ran out. She's like, I have all these papers. I was like, okay, I don't care. I told her that it didn't work.
Well,
So you can start looking at it. I would finish your lab, but yeah, this is, I'm gonna spend all next class together.
Is this the test?
It is the test.
Oh, it's take home?
It's take home. Yes, it is. Look at that. I don't want people to know. That's why next class, whatever questions you have on that, you ask me. I'll do my best to answer. I already helped Miles with 2 of them. I don't know if I was very helpful. Okay, good. I'll try my best. Okay. But you only get to hand it to me once, unless you do really poorly, and then I can give you another. That's why I'm here. Yay, hi. What's up?
Well, I was kind of doing like that. I was in
From this, from 25 to 22 to 21. Notice that it goes from left skew to symmetrical. Right, skew to symmetrical. So that's something you can change. You could also notice that it goes. What else do you want to know? The shape, oh yeah, the shape is this, that piece. So 0.5 stayed symmetrical the whole time. See, 0.5, all of them stay symmetrical. 0.2, we started right, and as soon as we pass 30, it's symmetrical. Now this one, 0.8, we started left, and as soon as it passed 30, so 48 was symmetrical. That's all you have to say. That this one is symmetrical the whole time. This one starts right, goes symmetrical. This one starts left, goes symmetrical. That's how the distribution is going to be. And then for this one, it says describe the distribution as between n change. Oh, that's this one. We did 2.
So the first one is just asking how these change, so this one for 0.5, as we go up. The X increases, the Y decreases, and these double every time, 2.55, 10, 20. This one, we start at 1. Doubles every time. 1, 2, 4, 8, 16, and this goes down. And this one doubles every time, 4, 8, 16, 32, they always double every time, and these go down. That's what you say for the first one. The second one we talk about, for purpose, we talk about this. So I have to say is these go up, these go down, we say they go up by doubling.
Okay.
And this is always half, you see how this is 0.5, guess where it starts? 2.5. And it doubles, see how this one's 0.2, guess where it starts? 1, and it doubles. See this one's 0.8, starts at 4, it doubles. So those are the patterns,
Okay, thank you.
write as much or as little of that as you want,
Okay.
you feel good?
Yeah.
Writing the parts?
Yeah.
Did I explain it okay?
Yeah.
Cool. How are you doing? Oh, okay. No questions? You feel good? Cool. How you doing? Good. You got it? You see the patterns? Awesome. Stop, share. So quiet in here.
And I'll send it to the other class.